When BM25 misses the right documents, clicks can become feedback. Rocchio turns those clicks into better query terms and stronger recall. This gives you the pattern for a system that enriches short searches and surfaces recall-improving expansions from clicks. I'm Professor Pi, teaching Search and IR with simple Python. Search engines often get tiny, vague queries. BM25 does a solid job with direct word matches, but it can easily miss documents that use different phrasing. That gap is annoying for users and for tasks that need broad recall. Think FAQ lookup or literature discovery. Rocchio Relevance feedback is a lightweight way to turn a few clicks into clearer query signals and pull those missed documents back into view. In a live system, this sits between the click log and the next query. Ideally, a relevant doc that was off the page moves into the top 5 after one quick expansion. You can try this on a small prototype corpus, or scale it into a service that refreshes expansions periodically. It's especially handy when clicks are sparse and you want quick recall gains without training a large model. At the core, Rocchio builds a new query vector by combining the original query with a centroid of clicked documents. For BM25, we implement that idea in token space. A seed keyword fails to hit a tutorial phrase. Clicks on a related article reveal the missing terms, and we weight those terms back into the query, so BM25 boosts the related pages. We'll walk a tiny end-to-end pipeline, a small corpus, a baseline BM25 ranking, harvesting clicked tokens, applying Rocchio weights, and rerunning BM25 to confirm recall improvement. The code stays compact, so the idea stays visible before you scale it. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To start, we need a tiny corpus and a BM25 retriever so we can inspect what it ranks and what it misses. This snippet seeds a tiny document set and instantiates BM25 Okapi for quick lexical ranking. Short exploratory queries on BM25 often start with a corpus that is too small or inconsistently tokenized. So we show the exact strings in docs and split them with tokenized docs. The call to BM25 Okapi builds term statistics that later steps will reuse for scoring feedback experiments. We deliberately keep sentences short so viewers can mentally map them to tokens when we inspect feedback weights in the next clips. The printed count confirms that the retriever sees 5 documents, matching what you'll expect in subsequent rankings. Now we need to run a query and capture the baseline ranks so we know what to improve. This example fires our first query through BM25 and surfaces the top ranks we get for the sparse token BM25. Short queries like this typically favor documents that echo the literal token, so scores makes item 2 dominate, while other relevant discussions fall to 0. Sorting the indices gives us a concrete list of hits and exposes which doc IDs we'll have to rescue with feedback. Highlighting that baseline value now sets the reference point for later recall games. The printed trio shows document 2 leading, with the helpful Rocchio article still missing. With the top hit identified, we emulate a user click and extract its words to build feedback signals. This code harvests fresh vocabulary from clicked results, so we can steer the next search revision. Leaving vague queries untouched means BM25 never sees the contextual clues the user already approved. So clicked IDs narrows attention to document 2. The nested loop ignores the original query tokens and increments feedback terms for every new word the student implicitly endorsed. Sorting those counts keeps the emphasis on the most shared concepts rather than one-off wording quirks. The printed feedback terms list confirms that ranking, tutorial, and retrieval emerge as the leading expansion cues. Raw counts are noisy, so we apply a Rocchio-style normalization to create smooth query weights. This snippet applies the Rocchio formula to the clicked evidence and produces smoothed query weights. Without this adjustment, the new vocabulary would overwhelm the seed. So Rocchio weights starts by seeding alpha before distributing pause scale across every term in document 2. Each loop pass adds a uniform share of weight, so longer feedback articles do not unfairly dominate the centroid. If you raise beta, the added words gain more influence, and lowering it keeps the expansion closer to the lone keyword. The printed Rocchio top list lets you see that ranking, tutorial, and retrieval now sit just behind the original BM25 token. Finally, we expand the original query with the top Rocchio terms and rerun BM25 to check recall. This example reruns the BM25 scoring with the Rocchio selected vocabulary appended to the query. Staying with the old query would keep document 3 invisible, so new terms strips out the original tokens and keeps the strongest additions. Feeding expanded query into BM25.getScores boosts documents containing retrieval phrasing, and the sorted re-ranked list reflects that change directly. The re-rank view pairs each document index with a rounded score, so you can see the improved separation. The printout shows document 3 breaking into the top ranks, demonstrating the recall lift promised by the feedback step. On a real project, you would map click document IDs to richer signals, weight clicks by dwell, and persist term centroids so they incrementally improve suggestions. The toy flow maps directly. Click harvest, centroid build, query expand, rerun BM25. A quick recap. Rocchio Relevance feedback blends your original query with terms from click documents to pull in related results you'd otherwise miss. Use it when short queries fail, and you have click signals to guide the expansion. One caveat: noisy clicks can drift your query, so limit expansion strength and validate against held-out queries. Next step: tune the BM25 K1 and B parameters while keeping the same Rocchio pipeline to find the best balance between term matching and document length bias. If short, practical IR helps, subscribe and watch the IR videos.